Hi, this is Andrew McLaren. Today we're going to be talking about modeling and using that as an assessment and how you can grade that in a similar format throughout the whole year to allow for students to get a lot of growth. So basically, the ideas I'm going to talk about are from this book, Joe Feldman's Grading for Equity. He doesn't talk about specifically modeling, but the rubric and my thoughts behind here kind of come from there. So if you want to know a little bit more about that, check that book out. Basically, for the rest of this video, we're going to talk about why you should emphasize modeling, how you're going to do that. And then I want to spend a fair amount of time talking about my journey with modeling because I'll help you understand what I'm emphasizing and why I'm emphasizing that. And then we'll look at the actual rubric and comments and how you can use a comment bank for that, as well as some examples of student work so you can see what this is all about. And you can skip ahead. There will be chapters in the bottom of this that should allow you to do that pretty easily. Before I do that, I did want to show you kind of where we're going so that you stay with me. So like this is a student made model. They made it in like a period, and I think they fixed it up like outside of school with me, but like they got it pretty much here at this level within one period, and they only needed to do some minor corrections. But like this is like very, very little that I did. It was pretty much all a student working on this with some minor feedback to help them. All right, let's get to it. So the main reason why you want to assess modeling is that's how you're going to get students to get better at it. If you just do a multiple choice at the end of the unit, students aren't going to get any feedback on what they were doing wrong in their models, and therefore the next unit, they're not going to be any better at it. So you really need to include this in your assessments and have a good way of giving feedback to students, to every student. And I'll go over that, how you do that in a little bit. But it's super critical that the students understand what they're doing right and wrong with modeling. And the reason that I emphasize modeling so much is this is huge in science. You have to be able to develop models and work with those models. That's what scientists actually do, right? So the NGSS, the Next Generation Science Standards, they've got 8 practices, and anything in science can kind of fall into one or multiple of these practices. And modeling, you can see it's like developing models is one of the practices. But I think you can also justify analyzing, interpreting data, especially with graphs, as a form of modeling. And same with formulas. That's a model of the real world, right? These are numbers and relationships in a formula that models and what we see in the real world and how those things are related. So if you have a good score for these different practices, you can have like assessments related to modeling and then have like a modeling score. So instead of just having like a grade for the whole class, kind of like in language arts or math, they'll give students like specific scores on specific skills, like, oh, their reading's at this level, their writing's at this level. And you can do the same thing with modeling. You can say their modeling is at this level based on these assessments. It doesn't have to be an average. See my video on retakes on kind of grading practices to help understand a little bit more about how you could take all those scores and kind of combine them into a grade using proficiency grading. But this also pairs really nicely with CER because you can have like a CER grade and you can have like a modeling grade. And I was thinking there's other things like a research project. You can have a grade for being able to do research and work with like databases and cite sources. That's totally a part. You can see that obtaining, evaluating, and communicating information is part of this. And so you need to be able to do that. There's also engineering that you could do. In any case, you want to have this skill throughout the whole year. And so you want to make sure it's in your units and that you're assessing it appropriately so that students get better at it. And I really, really like using Google Slides because it's widely used by elementary schools. So if you're working with middle school students in the United States, most of them have some familiarity with Google Slides and moving things around and some of the tools. It's also free. Like to anyone with a Google account. You can make a Google account for free. So it's very accessible for people from anywhere to be able to kind of make models in a slide. And it really, really integrates well with like a learning management system or LMS like Canvas or Blackboard or Google Classroom. Because Google Slides, you can make like individual assignments for students. That works really, really good. And then you can grade through them using like comment banks. So I'll go a little bit more with like the rubric and the comment bank soon, but that will be later in the video. And it's very, very versatile. That example I showed you earlier, you could imagine if you did something wrong on this, rewriting this whole model is a huge pain. Going back to your old Google Slides and moving some things around or changing the color of something does not take very long. Redrawing the whole thing and then changing colors on things, yeah, that's going to take a long time. And that's not what we want to emphasize. This isn't um, an art thing doing the model. It's more about showing the understanding, right? So we want to make sure the time is used on showing understanding and not making another piece of paper, right? So I would really encourage you to use Google Slides with your models or some other way of working online and sharing those files with you and then being able to go back and fix those files. Okay, that's the why and why you would want to do it the way I do it. When we're thinking about how we're grading modeling, the rubric and the expectations are going to affect the model that we ultimately get. So we want to think about these expectations kind of in a broad sense before we get to the specific rubric and specific comments and how I do the technical side. So the technical piece will be a little bit later. This is more like kind of big picture, how you structure the class to allow for modeling to be graded in a similar to way to what I did. So I'm very, very happy. I had a lot of growth from students, and I felt, and the students felt as well, that if you were doing test corrections like a second or third day or even a week later, everyone felt like they had no advantage over the students who just completed it in class the first day. It felt fair to everyone. And that was mostly because the feedback that I was giving students was kind of pointing out incorrect things in the model without telling them what would be correct. And then they had to figure out why it was wrong and resubmit it with those corrections. And because it wasn't multiple choice or anything, they couldn't really like cheat or get a model from someone else. And if it looked literally copy paste, same circles, same colors, everything as another student, that's a little bit suspicious on a model that we're making it without talking to people, right? And I didn't have any issues with that because of how it was structured. So also you can see version histories if you're in Google Slides, so you can see if they were working outside of class, or if you want to make sure that they're only accessing it in class, you can easily check that, which was something that I was doing. Make sure that they're only working on this in class because they can't do this at home with someone else possibly helping them, right? But it was also designed with the expectation that they would be doing retakes in mind. So like whereas most students completed this in one period, um, a lot of people needed to resubmit it, but they didn't need to work on it for more than like 5 minutes after they saw their feedback. It was very, very quick. So if you have like a study hall kind of thing, which the school I was at did, works very nicely for that. If you don't, you may need to have some separate space in your room for students to work on this during class. That was something that I always did, setting up some individual space, because students have a hard time outside of class taking tests, or asking them to come in during lunch is really hard for some people because that's like their social emotional needs need to be taken during that time. So I don't feel like I want to take kids in during lunch or after school and make that required. So I wanted to make it available to them in class to be able to do retakes. It's also important that you're not telling them, hey, this is what would be correct, or like you did bad here, but you can just say particularly like, oh, this looks there should be two phases present here instead of one, or something like that. And so it doesn't really tell them exactly what they need to do correct, but it tells them that the general area with what's wrong. So it doesn't really matter if they got it the first time. That's not a big deal to me. It's more about them getting it at the end, right? And so because this can take some time to grade, I recommend you do this not like the week before finals. Give yourself some time to grade these things, get them back to students, and then give them some time to do the retakes before the end of the unit. Just keep that in mind. It'll take some time to do this. Um, and I always let students test up to 100% because again, if this is designed correctly, it is totally fair for students who spend like weeks on this to do better. You know, if you put in more time and you end up having a better understanding a month after this, you still have a good understanding. And I think that the assessment should show that you understand this part of science modeling, right? So I was always willing to take retakes up to 100%. And also, if you've got some familiarity, that really helps. So throughout the unit, I was talking to students, giving feedback on what I was seeing in class, thinking about my rubric, being like, you would lose some points if you did that on the assessment. So I was kind of walking around actually telling them what was wrong and right the couple days beforehand and the models that they were building and the activities beforehand. So here let's pause and we'll go over this soon. Before we show you my current method, I kind of want to show you my journey with modeling to help you understand kind of my struggles and my reference point on modeling and why I'm emphasizing things in certain ways. So this is my 7th year being a teacher, and I have done a lot of modeling at like the 6th, 7th, and 8th grade. And I've just kind of picked out a couple things to show you. It's not a complete list of everything that I've done with modeling, but it helps you kind of understand where I'm coming from. So I've done, assignments where students have had to do kind of like these Venn diagrams. That's a type of model. It's heavily structured. And then I believe that this was also something that was on the assessment, but it was with multiple choice questions as well. And it was just for like points. It's just like, here's like 5 points for doing the Venn diagram on the assessment. So I'd given them some practice in class and then also expected them to do that model on the test. But it was just kind of like getting the things in the right categories, right? Um, and then I've also done things where I made like this cell analogy project. This is, doing modeling group projects is really inequitable. You got to be careful with doing any group project. The Joe Feldman book that I mentioned earlier basically says instead of giving everyone a 50-point grade for the group project, just get everyone's points for the section they're responsible for. So if there's 5 people, 10 points each, it's just a 10-point assignment. And they get their 10 points for their section and they're excused from the expectations done by the other people in the other sections. That's not what I did, but that's what I would do nowadays if I were to go back and do this project. So this was basically some analogy. They had to make some sort of analogy with organelles in there. Kind of see that there was some sentence frames where they had to say some analogy organelle and kind of explain it a little bit. So that's like a different type of model, right? Than what you may typically think of as a model, right? You probably think of like the water cycle, right? But if you look at the NGSS standards, you gotta be careful with what they do there. I want to show you just kind of like examples of student work from that project as well, just because, it's kind of cool to see different ways that people do models. And so this was a cell project. Obviously, I wasn't very happy with this because it's like what's what, like, is kind of, I guess it's an okay model, but it could be stronger. And it's like, well, what is missing, right? I had a hard time with like what was missing, with why I liked some more than others, and I was able to give points for doing certain things, but it felt very kind of um, inconsistent between different assignments. Like the expectations were clear for this, but why this was a good model compared to another model was kind of unclear. Or why one person's project was better than another person's project may have been a little bit unclear to students. So I had like a schedule and all kinds of really cool things, sentence starters for them and group contract. Pretty good project, but I would change like some of the expectations with how I scored things. This is an example of a similar thing where they had to. I would argue that this is modeling, but with analogies, where they had to explain why certain organelles were like certain companies. So that was kind of related to modeling. Again, kind of a stretch, but you can kind of see how it's like, well, where is modeling kind of coming into the grade here? And as a parent, like you're gonna have no idea if your kid's good at modeling or not if they failed some of these tests without actually looking at the questions, right? So we want to communicate more information to parents and students about where their skill gaps are. This is just a regular assignment done in class. No real expectations on it. Just kind of like do it, take the observations, right? Not ideal. But I mean, I think we do that a lot with assignments. But then it's like you want them to be thinking about why their model is good or bad. Um, I've also done things where I've done like creative writing projects with the water cycle where they have to explain what's going on with energy changes and states of matter. And I gave a huge list of expectations around that. And so you can kind of see what students did with that. So this is a version of a model in my mind because it's showing how matter is moving. And there was like expectations, not just like to say like, oh, this is my path, but to kind of talk about how your path is a little bit different than other people's, um, which was something we saw in the simulation as well that we actually did with people moving around. But this is just kind of like in my mind, this kind of falls under the same category where this is a type of model, uh, but it's a written story that explains the relationships, right? I've also done like when I was doing eighth grade, doing Punnett squares. That's definitely a model. This is a pretty good quiz. Like you can give kids like an 8 out of 10 or a 7 out of 10, but what is 7 out of 10? Good. You're good at this. What are they good at? What about making a model did they do correctly? What did they do incorrectly? It's kind of unclear. Um, and it doesn't really show like a student's strength in modeling um, when you do that. So then there was also I've done things with like uh, this body system project where I had them draw something from memory. Again, no real expectations, just kind of do it, which is a lot of my modeling. Honestly, when I was looking back at it, I was just like, make a drawing, show some motion. Like I think I did something like convection currents, where I was like, show the convection current using arrows, and the kids were like, you haven't taught us how to do that, and I it's weird that you have to teach people how to show motion with arrows, but you do. Like you need to have them look at different examples, compare them, and say why one is better than the other, something like that, right? Again, similar sort of thing where I'm like, make a model of this and try and include some things like some vocab words. So there's like some things where I'm like, you have to use this word, right? So that's going to come into play. Then there's also this huge unit that I developed last year, and this was really, really good. I did a lot of good things that supported the students making better models. It's I'm actually kind of in love with what I did with a lot of these things in this unit, where students would like draw things on Google Slides, and then they would have to get feedback on them basically, where I had like discussions around common misconceptions I was seeing. And so students would make a model, and then I would look at those models, pick a couple of them, and put them like in a discussion. Like this is you can see this is a discussion where there was some examples of student work, and we talked about it, and students put comments on there and responded to each other about which one they thought was the best model or the most accurate model, and I gave them some sentence frames. So that was like I was getting a little bit closer in terms of supporting the models being made. I was having them give feedback to each other, having them work on these Google Slides. Um, it it worked out pretty well, but the I didn't really do a modeling assessment that year that I did that. Um, I did the modeling assessment this year, which was the following year after I kind of played around with that. So I made that. That was like COVID year, developed that on my own. Pretty proud of the lessons. But then I taught with the fall in the following year, I used Amplify, and I used what I learned there to inform my current approach. Because I knew that I was getting the class supports around the modeling, and I knew what I wanted with these molecular models, but I was having a really hard time um, figuring out how to assess that and do that fairly, right? So I'll show you how I figured it out in the next bit. So the rubric that I'm going to show you has only been used with one topic so far, but I've designed it so that the categories could be used for any prompt. Like you could be doing ecology and like you could be doing carbon cycles or weather or all kinds of stuff, right? You could be doing like plate tectonics and trying to do a model of that. This rubric should work because I've designed it around what I was reading with NGSS practices and performance expectations. And I'm going to show you this rubric in Google Classroom as well as the comment bank because they're very, very efficient. They'll save you a lot of time and make grading these actually doable. If you look here, this is basically the rubric, and I've got like strong, good, weak categories, and then the different or the scores for these different criteria, like getting the distances done correctly and the time done correctly, getting any changes, making sure those are clear, making sure like things are labeled correctly and the relationships are also correct, and then limitations of the model. Now, if you think about that in general, all modeling should be able to be scored in those relative categories. Um, and then you can tweak exactly what goes in here depending on the prompt. So you're gonna have to have like different vocab words that are being labeled depending on the model, right? Or you might have to show the instead of saying molecules here, maybe it's planets or something, right? So you've got the spacing between the things in there. And then I also had these comments that if they didn't do particularly well with that section, I had a generic comment that I was able to use with Google Classroom to easily type these in for that student very quickly. Um, you just press like 4 keys and the whole thing comes up. It's pretty awesome. Um, and so I was able to give detailed feedback that was specific to categories. And then I could tell someone, hey, you're not doing good with your scale on your distances here. That's what you need to work on this model. Um, and then I can look at their ability to do that in a different model. Were they getting their distances done incorrectly in this other model as well? Maybe we need to talk about doing things to scale and what that means, right? Or if there's another student who's forgetting to label things consistently, then that's something that we need to identify and help them do better with doing labeling things better in the future and go over keys and spend some more time with keys with that student, right? So there's all kinds of things that you can get that's useful by looking at modeling a little bit more holistically throughout the whole year. So to help you kind of understand where that rubric came from, this is what they say about modeling in like elementary school and middle school. Something that just jumps out right here is limitations of a model, right? So I included that category because that is something they want us to emphasize. And then talking about things that are changing, they need to develop and modify their model, right? Because so we're getting better models. That's kind of like the whole process that we're doing. Um, and like what we're doing is, yeah, like I think you'll see it a little bit more in like the thing that's a little bit more particular to what we were looking at. So this is like the standard where they need to develop a model showing the motion and temperature of these pure substances when thermal energy is kind of coming in or leaving. And so we looked at just one phase change and we focused on what's going on with that particular phase change. And the nice thing about that is that you could, if you wanted to do retakes, you could have them do a different phase change, right? Pretty easily. And instead of um, maybe like liquid and gas, maybe it's going to be liquid and solid. So you might need to change the vocab words slightly if you were to do like a different version for people that need to do a retest, if you felt like doing that. I would not personally do that because I felt like them going back and fixing their mistakes was showing a lot of understanding. Um, So this, you can kind of see a little bit about like the spacing, right? So there's things that I'm seeing with spacing in there. So I was like, okay, that's the scale factor. Changes, making sure that the changes are clear. So you can kind of see like, I kept on seeing these things in all these rubrics, and I started making categories and tweaking those categories. And then for this particular thing, they also have the particular expectations. And you can see like, oh, relationships, right? So I'm talking about like vocab words, basically showing some of our relationships in there. And if you read through this, you'll probably see some things that I'm not seeing right now. But there's like a lot of labels on in here that you need to do. Um, Motion. I think that there's some stuff in here about motion, right? Yeah, so you need to show that motion, and you need to be talking about like kinetic energy and how that relates to the motion, all this stuff, right? So there's a lot of things that you need to show. Um, and I try to break those down into categories, give specific feedback about those categories, and then help students improve that, right? This is what it looks like kind of in Google Classroom. So I've got my assignment that I've turned in here with some work on it. This is actually a student's project that they submitted, and I just retitled it and submitted it here. So this is kind of what the assessment looked like. There's a video that kind of went over the tools to make sure that they knew in general how to use this stuff, as well as a link to the rubric. And just general expectations saying, hey, you can do retakes, take a deep breath, you know. And then there's the prompt where we've got our thing. This is a prompt from Amplify, but I've tweaked it a little bit in terms of the how I'm measuring this and how I'm having students show this understanding. They had them do a CER, I think, which was completely inappropriate for the standards that we're covering. It should be a model. So I tweaked that to make that the final assessment for that unit. And then you can see right here that this is kind of all these comments on here. And if you click on the comment, it kind of highlights the section that I've put the comments on. And so you can point essentially to a section like how you would with your red pen and be like, this is done incorrect, right? And you can click on something and you can go to your comments. So if you right click on that and you go to comments, that's one option. If you don't have a million comments in the side, you can also, I think there's like a comment button that sometimes pops off to the side here. And these all, I think, were, yeah, all three of these I highlighted. That's why that's showing up there. Yeah, so if you right click, you can put a comment on. And so if you're like, oh, I want to put a comment on this particular part to tell them that they missed their labels, our comment bank should make it fill in once you start typing it in, right? Or if you're like, oh, phase, there's something going on with phases that's done incorrectly, and then you can put that on there. So you just type out, and you'll get an idea of which words bring up which ones the fastest, or like the minimal amount of things that you need to type based off of your comment bank. I would really like it if you could have different comment banks in here, Google, if you're listening, like different banks for different assignments. So you could have like a claim evidence reasoning comment bank, and a modeling comment bank, and a research comment bank, right? All those things would be cool if you had different, slightly different but similar comment banks. So that's the comment bank. You can add comments on there. And then you can also have the rubric right here. And so you can just say like, oh, they scored like a 1 out of this or a 3 out of 3 or something. And the students will see this in Google Classroom. Like the rubric does appear to them as well. And so they can see how they did on those different categories. And then if they're like, oh man, I want to fix up that category, they need to look at their comments and figure out what they did in particular that was wrong. And then they need to figure out on their own what that should look like, right? And so they've got these different comments on here. And this is, it's not that hard to put a rubric on an assignment in Google Classroom. You just go ahead and try and make an assignment. And then the rubric is right here. You do have to kind of plug it into their format. But it is well worth it. It will save you so much time with grading. Oh my gosh. Like seriously, it cuts the amount of time that you spend grading on these things in like to like a tenth or like a 20th of the time that you would normally spend otherwise if you're trying to do this level of detail and feedback, right? Um, but it is manageable if you have the rubric and the comment bank. And then you can also just do all your grading in Google Classroom, no paper. You can do it at home. You don't have to be, you know, bring all these papers back and forth. I used to bike uh, to and from work, so that would not have worked well for me. I've got some examples of student work that was submitted for my particular prompt around phase changes. Um, and they're pretty good. Again, these are a lot of them are like their second or third attempts after they've fixed them up a little bit. Um, but I got a couple that were like this on my first attempt, and like of course like they've got no labels of their phases, the spacing's wrong, there's no interactions shown. There's a lot of things that could be done better about this. So this would have had like a million comments on it. And then they fix that up, right? And then like you can kind of see that they did a better job with the energy, but there's definitely something weird going on in terms of them modeling out phases because they knew that there was a liquid and now there's a gas, and that does not look like a gas to me. So this student definitely has some significant gaps, right? This student, a lot more is understood, and I can see a lot of information here. Like I can see the phases they're labeled, so that you got your points there. They've got energy kind of coming into the system, so that's gonna help you get points for that part. They've got like the spacing between these atoms done correctly. They've got interactions done correctly. And I should also probably mention that if you did one thing wrong in the distance section, you're gonna lose points for that section, right? And so there's a lot of things where like they did pretty good in a number of parts, but they missed one part about the distance. And if they fix that, then they get full points, right? And so there's a lot of things that you can kind of see different between those, and you can kind of see why I'm happier with like something like this than that first one. And so I had some good comments to help people get closer to this. Again, you can kind of see that this student's got like their speed shown by like the distance of these traveling, so it's like going faster because it's longer, right? um, and they're showing energy coming in, and that's got the key here, so like they didn't need to label that necessarily, but like they're missing like their phases, like they haven't labeled liquid, solid, gas. So you can kind of see in my process of how I was grading this, and I would just kind of go through the categories and be like, is there anything missing from this category? And I'd be simultaneously putting comments on, right? It takes a little bit of time, like for real. But once you start kind of seeing things and knowing what to look for, you get pretty quick at it. Like for example, this one, it should be a liquid at first. This looks like a solid, and then maybe a liquid and then a gas. I think these are like the three phases that they've drawn, whereas it should be a liquid and a gas, and then this middle should have both liquid and gas, because during evaporation, some of it's still liquid, some of it's turning into gas. So like there's some things that weren't great. You can also see that they've got molecular attractions being shown, but then like I'm not sure what's going on with the motion here, because this looks like things are vibrating, but it shouldn't be vibrating if it's in a gas. So like there's a number of things that you can see where it's like, this is pretty good. You did this correct, but not that. And so I was able to give consistent comments that were clear and led to a lot of growth, a lot of improvements in their model. And so you can see like this example where I've just got a million things labeled on this one about what they did incorrect. And for example, this one, I was thinking about looking at this from like the side perspective of like a cup. And so like the liquid should be in the bottom. Um, there were other ways to show that the liquid takes the shape of the container but doesn't fill it, but that was the easiest. So I recommended students try and put the liquid at the bottom of the container and kind of show the gas filling up more of the top area, right? I think one of my comments was like liquids should be on the bottom of a container. Again, this one's, it's better than that first one I showed you. You know, got spacing done pretty good, but I'm not really sure what's going on with these lines. I think they're showing the speed that things are moving, but the arrows aren't tied to a particular atom. And then also it's like, wait, is this speed? Because now you're using solid lines and dotted lines. What's what? Because I thought path was dotted line and attractions were solid. So there's a little bit of inconsistent use in some of the symbols there. So it led to some possible confusion, right? So you want students to be as clear as possible. Even if you're like, yeah, I could probably figure it out. Students should try and know how to make it so that you know how to figure it out clearly. And then this is one of my students that did very, very good. I think this is almost exactly what they turned in, but there was one comment that I put on, like, you didn't label your phases. And so she just threw those on there and then these colors, and that was good enough for me. She showed me, she knew where the liquid, the gas, the evaporation were happening. So that worked pretty well, right? That's basically a pretty good sampling of what I got back from students when I gave them that rubric and comment bank with clear expectations and plenty of time to do retakes. It was pretty good. I was pretty happy with it. So you can, if you're curious about getting this particular assessment and this rubric and everything, I have this on Teachers Pay Teachers, and I'll link that as well in the video. If I don't, please put a comment on there to remind me. But you should be able to get the assessment and see. There's also a modified version that I had made. I don't think I showed that in here. Kind of. I don't know why. Let me show you real quick. Okay, this is what you get with Teachers Pay Teachers. You get the rubric. You get like the rubric that I was showing you earlier with some of my comments. You get the assessment, like the regular version. I think. Oh no, this is the modified version. Yeah. So I've started one of the models for them and I've given them the vocab words over to the side and they just need to put them on there. So this is slightly modified. And then I also, the week before, I gave them a practice version that had a different phase change in it. So it's the exact same format, exact same question, slightly different rubric. I think that the rubric was just modified for that different phase change. And I didn't score this in Google Classroom. This was just like, hey, you guys try it out. And I actually had only one student talk to me about that, but they talked to me the day before the assessment and they're like, hey, Mr. McLaren, did I do this correct? I want to know before the assessment so I do good on the assessment on my first try, right? It's like, oh, feeling pretty good about that, you know, kid working hard, doing extra work outside of class so that they can show their understanding. And they, by the way, they got a perfect score on their first attempt, that kid. So it was pretty cool and they were very proud. So yeah, I think that that's everything that I've got to show you guys. This could be easily adjusted to be done with any topic. So let me know if you need help with that. All right. Thank you. Bye. Thank you for McLearning with me. I've got a few more offers that I'd like to let you know about. And remember, like and subscribe. For each video on YouTube, I am making an interactive version using HP5. These will be for sale on Podia. And if you click on the link in the video, you should be able to go directly to that product. I also have 2 demos I'm going to be linking so you can kind of see what these products look like. So I would recommend checking out those demos. I also offer one-on-one remote tutoring through Wyzant. Please use the links that I have linked below. That way I can get 100% of the hourly rate as opposed to 75. Each video also has a link for my Patreon, and you can join at the $3 level to get some resources I use for tutoring or to support the channel. And I also have a $5 raffle level, which you could either get some free online tutoring or 5 interactive lessons for free. You choose which ones. And then I also have my Teachers Pay Teachers, which has some old lessons that I made from when I used to be a teacher. I may be adding to that. Thank you for spending your time with me. I hope that you learned something.